How to Draw Convex Lens Ray Diagrams by KayScience.com. This is the problem you will learn how to solve. Press pause to attempt it. The method and the answer will follow. This is a convex lens, and these here are the near side and far side f and 2f points. I've drawn an image between 2f and f on the near side. So this is an object that is between f and 2f, between f and 2f. So from the top of the object, we draw the incident ray parallel to the axis, and it then refracts through the convex lens, through the principal focus point on the far side of the lens. You then draw an incident ray being reflected from the top of the object that passes through the center of the lens. And this is where the rays meet. So the image produced by an object on the axis between f and 2f is a real image, and it's an inverted image. So it's a real inverted image, and the image is beyond the far side 2f. So the image formed is beyond the 2f point, as you can see here, and the image formed is larger than the object. This is the image formed by an object on the axis between f and 2f, between f and 2f. This is the problem you will learn how to solve. Press pause to attempt it. The method and the answer will follow. This here is the axis. This line represents a lens. The lens is drawn perpendicular to the axis, and the axis runs through the center of the lens. So to differentiate between a convex and concave lens on a ray diagram, you draw arrows on the top and bottom of the line. If the arrows point away from the axis, this represents a convex lens. And this line is the axis. This is the object on the near side of the lens, and it's a strawberry. So to draw the ray diagram for this convex lens, you draw a line from the top of the object running parallel to the axis towards the convex lens. The refracted ray will pass through the far side principal focus. You then draw a light ray travelling from the top of the object through the centre of the lens. And at this point, this is where the converging rays from the top of the object meet. You then draw a line parallel to the axis from the bottom of the object towards the convex lens. The refracted ray from a light ray travelling parallel to the axis is going to travel through the far side principal focus. And then you draw a light ray travelling through the centre of the lens. And these two light rays from the bottom of the object are going to converge and meet. And you can then draw the projected image that has formed on either the screen or the back of the retina. And this here is the image formed. So the image formed is a real image. It's an inverted image, which means it's upside down. And this image is larger than the object. So this here is the convex lens, represented by two arrows pointing away from the axis. This incident ray travels parallel to the axis, then refracts through the convex lens through the principal focus, through the principal focus. And this incident ray from the top of the object is going to travel through the center of the lens. It will continue straight on and converge with the other light ray, and this is where they meet. And this is where they meet. So remember that incident rays that are parallel to the axis on the near side are going to refract through the convex lens and then pass through the far side principal focus. And this ray is going to travel straight through the center of the lens and converge with the other ray, and they're going to meet here. And this is where the real image, which is inverted and projected onto a screen, is produced. This is the problem you will learn how to solve. Press pause to attempt it. The method and the answer will follow. So this here is another lens, but we know it's a convex lens because the arrows are pointing away from the axis, as you can see here. So it's a convex lens, which bulges outwards like this. These two dots represent the far side and near side principal focus. So this here is an object on the axis between f and the lens. So it's between f, which is the near side principal focus, and the lens. So what is the image that's going to be formed from this situation? So we draw an incident ray from the top of the object, which is parallel to the axis, and it refracts through the convex lens and passes through the far side principal focus. We then draw a line from the top of the object down through the centre of the lens, and because both of the refracted light rays are diverging, they're not going to meet on the far side, so we draw virtual rays that go behind the object. So where the virtual rays meet is where we see the image coming from. So there is a larger image behind the object, as you can see here. So this here is the far side principal focus. So this incident ray, which is running parallel to the axis, is going to refract through the convex lens and pass through the far side principal focus. So this incident ray travels through the center of the lens. And these two refracted rays are diverging. They're moving away from one another, so they're not going to meet, and the image will not be formed on the far side of the lens. So what we do is we draw virtual rays. As you can see here, these virtual rays are traced back from the lens, and this is where the virtual rays meet. So the image formed is going to be a virtual image. It's not a real image. And virtual images are upright images, and the virtual image is on the same side as the object. And in this case, the image is larger than the object. Press pause to answer the questions. The answers will follow. And if you're stuck, just re-watch the video. Press pause to go through your answers and make any corrections to your mistakes.